All right, so today we're doing lesson 2 in logic. We're only learning new information in lesson 1 and lesson 2. Lesson 3 is your project, and then you're going straight to the unit review. Not a long lesson, it's just a lot of vocabulary. Blech. All right, so we're going to talk about biconditional statements, the law of syllogism, and truth tables today. So we're going to jump right into biconditional statements. Biconditional, bi means two. Bicycle, 2 wheels. Biped, 2 feet. Okay? Biconditional, 2 things have to be true, not just one. So in a conditional statement, only the first statement, the if statement, has to happen. In a biconditional statement, both parts have to happen. And we show this by writing if and only if. So we're taking the then out of the statement and replacing it with a if. So what changes also, see how the arrow now, instead of it going in just one direction, because only one thing needs to be true in the first statement we learned, the if part, now both parts have to be true. The first part of the statement and the second part of the statement have equal weight. What? Let me show you what that means. First example isn't the best, but that's okay. If a figure is a square, then it has 4 sides. Oh, that's true. Both of those are true. Figure's a square, it has 4 sides. Okay? A square has to have 4 sides. So if we flip it and do the converse, if a figure has 4 sides, then it is a square. So let's look at this. The way we can say that, a figure is a square if and only if it has 4 sides. It cannot be a square if it doesn't have 4 sides. Instead of writing all those words out, just like before, instead of writing if and only if, you write IFF. That's what that means. Okay? So let's look at this next example. If an angle is a right angle, then it's equal to 90. Both of these are true. A right angle is equal to 90 degrees. If it's 90 degrees, it is a right angle. So both sides of this are true. This is a much better example. An angle is a right angle if and only if it is equal to 90 degrees. Both parts of these have to be true for that statement to be true. Oh, whoops. So I want you guys, sorry, I forgot. I want you guys to go ahead and do an add puzzle. So you're going to do 2 questions. You're going to do you try number 1. And you try number 2. All right, so now I'm going to the next page. So now we're going to go backwards. Now we're given the statement, the biconditional statement, and we have to break it into its 2 truths. So example 3, students are taking the PSAT if and only if they are 10th graders. What that means? What does that mean? Well, that means that if a student has taken the PSAT, then they are in 10th grade. And the converse also must be true. A student is in 10th grade, then they are taking the PSAT. So both of those have to be true in order for this to work. Okay, let's look at the next example. A figure is a square if and only if it has 4 sides. Okay, we already looked at this, so let's break this down. We already did this in example number 1. You can even look at your notes and you can predict, see, I'm looking at my notes, what I'm going to say. Okay, so if I break this down, if a figure is a square, then it has 4 sides. And then I take the converse. I flip the front and the back, right? I flip the hypothesis and the conclusion. If a figure has 4 sides, then it is a square. Okay, so we're going to write all that down. And then we're going to do the you try for number 3. You're going to break it into its pieces. So now you're going to write the 2 conditional statements that made your 1 biconditional statement. And now you're going to do number 4. Okay, and we're going to go on. To be biconditional, the conditional statement and the converse statement must be true. I've been saying this over and over and over. Now I want you to write it down. All right, we're not going to try and understand this table. The only thing I want you to look at is this first line right here, the PQ. So this is my conditional statement, right? If P, then Q, right here on the first line. If both of them are true, then the only thing that will always be true is the contrapositive. Look at this. If I'm just looking at the first line for here. If my P and my Q are true, sometimes the converse will be true, sometimes the inverse will be true, but the contrapositive will always be true, okay? So, if the original statement is true, then only the contrapositive is always true. I'm going to put my face up there so you can see what I'm doing. Okay? That's all I need you to get out of that table. Okay, so the original statement and if the original statement is true, if the conditional statement is true, then the contrapositive is also true. Because it's a negative negative, which makes it back into a positive. All right, true-false logic. So now we're going to just look at this logically. So let's read this statement. If we're at the White House, then we are in Washington. Is this true? Yes, it is. Therefore, it's valid. If it's true, it's valid. Okay? If I had said it the other way, if we are in Washington, then we are at the White House, which is the next example. That's not true. I could be somewhere else in D.C. I could be anywhere in D.C. If it's false, we use the word it's invalid, and then I can prove it's false because we could be at the Washington Monument, right? We could be at the reflecting pool. We could be at the Metro. We don't have to be in Washington, D.C. Sorry, it's 3 o'clock and my clock went off. Can you hear it? It's a mourning dove. All right, let's look at this one. The inverse statement. So if we are not at the White House, then we are not in Washington, D.C. Wait a second. My conditional was true. My converse was not true, right, when I flipped it. Now I'm doing the inverse. Is that true? No, that's not true. Same stinking reason, right? It's false because if I'm not at the White House, I could be someplace else and still be in Washington, D.C., right? That's invalid. We could be at the Smithsonian and still be in D.C. We're not at the White House. We could be at the Smithsonian and we're in D.C. That's not true. That's not valid, right? If we're not at the White House and we're not in Washington is not valid. So the conditional was true. The converse was false. The inverse was false. And I just told you that the contrapositive will be true. Let's see if that's true, right? If the conditional is true, the contrapositive is true. Let's see if I was lying to you or not. If we are not in Washington, D.C., then we are not at the White House. This is the contrapositive of the original statement. You can see it on your notes. You can't see it on the screen, but when you're looking at your notes, it's the top, this top corner right here, this one, the original statement. Let's see, is that true? Yeah, if we're not in Washington, D.C., we couldn't possibly be at the White House. So that is valid, right? If we're in St. Louis, we cannot be at the White House, right? If we're in New York, we cannot be at the White House. There's no way to make this, there's no argument to make this false. This is a true statement. Oh, so I just proved it. Conditional is true, contrapositive is true. Okay. Last thing we're going to look at is the law of syllogism, and I actually really like this. Okay. You guys have been practicing with your PQ statements. So if P, then Q. That's the first statement. That's my conditional statement. If Q, then R. What? There are two starting statements. Then, and I'm reading through all this, what? And then it would mean that P is P, therefore R. So let's not look at this from a lens on that top line right up here, because that gets confusing. And also I typed it wrong. There should be a space between the R and the P. I think there is on your notes. So let's look at this. If Bill pitches, then Tom will play first base. If Tom plays first base, then Ed catches. This is a rule that you actually learned in algebra. It was one of the first things that you learned at the beginning of the algebra year, but we're going to make this less mathy. You ready? See how it repeats? If Bill pitches, then Tom will play first base. If Tom plays first base, then Ed catches. Why would I repeat myself? I don't need to repeat myself. Just cross out what repeats. So I'm going to cross out Tom plays first base, Tom plays first base, and I write down what I'm left with. If Bill pitches, then Ed catches. That's what the law of syllogism is saying. It's simply saying you don't need to repeat yourself, right? If one thing is true and another thing is true, then the third thing is true. That's what this is, okay? This is important. Just cross it out. So let's try this one. If you are a duck, then you can swim. If you can swim, then you can fly. Oh, there's a repeat. Don't repeat. Don't repeat yourself. It's a waste of time. Cross out what repeats. You can swim. You can swim. Oh, if you are a duck, then you can fly. Just write down what's left. Oh, whoops, I wrote the wrong thing. Don't write that. Don't write that down. Whoa, oh my gosh, I panicked. Change the swim to fly. You write down what's left. So don't do what I just did. Do what I'm telling you to do. Do what I say, not what I do, right? Write down what's left. If you're a duck, then you can fly. Oh, and I can check and make sure that you followed the notes, like we're listening. Okay. So the only thing I want to go over is looking at this vocabulary chart on your notes. I'm not going to make you go over it, but this is important. You're going to need this to do your card sort. At the bottom of your chart, however, something got cut off. The therefore symbol. So at the bottom of your chart, there's a V, right? You see it on the bottom line, and that means and. So when you see a V in a statement, it means and. If you see an upside down V, or like a little mountain, or a, I don't know what you want to call that, I don't know. That means or. And the last symbol that should be there is this one. So you're going to write this in that last box. The 3 dots making a triangle means therefore, okay? You're going to need to know this for the test. I'm not really going to stress about it, but you do need to know it. So I want it on there, and you're going to need it for your cards, okay? All right, so after this, what you're going to do is you're going to do your card sort, and you're going to do a worksheet. I don't care which order you do them in, but the card sort has to be signed off. You can't just say you did it. I have to witness it. So I have to see your sort on the table and initial your sheet. Okay? Thanks, guys.